Hello and welcome to our first lesson of Calculus and Vectors. In our first chapter, we're looking at an introduction to calculus. So we're going to get started with just a review of some prerequisite skills that you need from past courses. The first one we're going to take a look at is slope. So this is the concept that we cover in grade 9. If we give you points x1 and y1 and then a second point x2, y2, then you can calculate the slope by taking the difference in the y values over the difference in the x values. Notice that the points have to come together. So the second point here is first and the first point is second, or you can do it the other way around and write those with the first point first and then the second point. For the equation of a line, we use the form y equals mx plus b, and we're going to do stuff like this as a step within our calculus questions. So finding the equation of the line will be like the last step in some of our calculus questions. So for the first one, we're going to find the equation of a line, and we're given 2 points here, x1, y1, and x2, y2. In order to find the equation of the line, the first thing I have to do is find the slope. So I'm going to start with my equation. For finding the slope. Oops. And then I'm just going to fill in the numbers that they've given me. So again, I'm going to put the second point first, and then I'm subtracting the first point. Don't forget that when you subtract a negative, you do need to put brackets around that, and it's going to turn into an addition on the bottom. So we've got negative 4 over 6, which reduces to negative 2/3. And now we can find the equation of the line. So to find the equation of the line, we'll start with, well, we know what the equation looks like, y equals mx plus b, but now we know the m value. So the only thing that we're missing is the b value, which you might remember is the y-intercept. So what we're going to do to find that is sub in one of the 2 points. It doesn't matter which point you pick. I usually just pick the one that looks like it's going to have some easier arithmetic for me to do. So here what I'm noticing is the m value has divided by 3. So I want the x value to be something that divides easily by 3. Now both of these x values are easily divisible by 3, so it doesn't really matter which one I choose. I'll probably pick the one with the positives. So I'm putting in 2 for the y and 3 for the x. And now, like we said, we're going to have some easy canceling here. I've got 2 times 3 divided by 3, so the 3's are going to cancel out, and I'm just left with negative 2. And so I'm going to bring the 2 over and add it, and I get b is 4. And then don't forget to state your actual answer. What we have figured out then is that the equation of this line is negative 2/3 x plus 4. All right, some other things that we need to remember then are the average rate of change, which is very closely related to that slope that we were just taking a look at there. The average rate of change is the slope of the secant. So remember, a secant is a line on a curve. So if I had a curve like this, the secant would be the slope through 2 points. So maybe I pick this point, and I'm looking at the slope here of this line. That would be slope of a secant. And to do that, I just do the same thing, the difference in the y values over the difference in the x's, except here we use our function notation. For instantaneous rate of change, instead of looking at the slope between 2 points, like here, this is our secant line, what I would be doing is looking at the slope at 1 point on the curve. So for instance, if I picked this point here, then I would draw my tangent line just passing through that 1 point on the curve. So if I zoomed in really closely, that's the only point that it would touch the black curve. That would be my tangent line, so slope at 1 point. And that's our instantaneous rate of change. We approximated the instantaneous rate of change in the advanced functions class by using the slope between 2 very close points. So we chose the points with the x value x, and then we picked x plus h, and usually for h we used 0.01 in the advanced functions course. We're not going to do that in this course here, but that's what we were used to before. Notice that when I simplify this in the denominator, when I subtract those 2 x values, the x's cancel out and I'm just left with h. We call this bit here on the end, we call this the difference quotient, and we're going to use this in calculus as well, but we're going to use it to actually calculate the instantaneous rate of change instead of just approximating it and getting close. All right, the last thing that we need to talk about is piecewise functions. So normally this is covered, when I teach advanced functions, I cover this in advanced functions, but it wasn't this year. A piecewise function is when we want to define a function with two or more rules, so like two or more equations. So it's the same function, but we've got two or more equations, and then we're going to use two or more domains. So we've got different equations and different domains. In order for this to be a function, the domains are not going to overlap, right? So I'm going to have one thing happening, and then at a certain time it will change and another thing will be happening. So a couple of real life examples of when this might happen. The first one is a skydiver's height over time. So first the skydiver's falling really rapidly, right? One thing is happening, and then all of a sudden the parachute opens, and now his height over time is changing at a different rate. And then, of course, when he lands on the ground, something different is happening again. So we can take a look at this. Here I've got the height on the y-axis and the time on the x-axis, and we're looking at first the skydiver jumps out of the plane, and his height starts to decrease more and more rapidly, right, as gravity takes effect. And then he opens up the parachute, and then he's going to fall more gradually to the ground, and then finally he's on the ground here. So there's one example of a piecewise function. So I've got different things happening. At first it looked like a parabola, and then it looked like a linear with a negative slope, and then of course a constant or a horizontal line. The second example that we could take a look at is when a data plan for a cell phone. So the price changes depending on the number of gigabytes used. So this is usually tiered for prices for different intervals. So again, I've got a graph of that we could take a look at. So for this plan here, it looks like it was $10. So I've got the cost up the y-axis and the number of gigabytes used along the sorry, I think this is actually number of megabytes. Yeah, this is number of megabytes along the bottom here. So for the first 100 megabytes that you use, it's only $10. And then there's a second tier here. If you use between 100 and 500 megabytes, then the cost is $30. Notice that these lines end in closed circles and open circles. And that's so that it is still a function. So if I look above 500 megabytes, then I've got an open circle. It gets really, really close to 500 megabytes. If you use 499 megabytes, it's $30. But as soon as you hit that 500 mark, you jump up to this tier here at $45 for the 500 megabytes. And again, up to 2,000 or 2 gigabytes, and then it's going to jump as soon as I hit that level up to the next price point. All right, so we're going to take a look at an example. So this is how we would write a piecewise function. So the function is f at x, but it consists of 3 different rules and 3 different domains. So the first rule is a line with a slope of 1 and a y-intercept of 2, and that line is going to exist for all of the x values less than -1. And then all of a sudden it's going to switch over to being a parabola, and that's going to exist from -1 to 2. And then it's going to be a horizontal line after that, a horizontal line passing through y equals 3, and that's going to be true if x is bigger than 2. So our job here is just to calculate each one of the following. So for f at 0, I'm given the x value of 0. The first thing I need to decide is, well, which of these domains is it in, so I know which equation to use. So if I've got x is 0, I'm in this equation here, right? It's between -1 and 2. So I'm going to use y equals x squared. So then I know that f at 0 is 0 squared, or 0. Now, for the next one, I'm looking at f is -20. So where is -20? I look through my 3 domains, and I see that -20 would be less than -1. So I'm going to use this time, I'm going to use y equals x plus 2. I'm going to use the first equation here. And so f at -20 is equal to -20 plus 2, or -18. All right, so then what about the next one? Well, the next one is x is 5. So x is 5, that's going to be in this one here. So for this calculation, I'm going to use y equals, and it's just 3. Y equals 3 is the rule. So f at 5 then is just equal to 3. There's no x for me to replace with a 5. It's just a horizontal line. The y value is always 3. Now the last one is a little bit trickier here. We've got x is 2. Now x is 2 is tricky because I see a 2 here and I see a 2 here. So which one am I in? Well, here I want to, this one here says I have to be strictly greater than 2, not equal to. I need this guy here because he can be equal to 2 as well. So I'm going to use y equals x squared, and f at 2 is 2 squared, or 4. And that's it for today's lesson. You can find the homework on the homework log.